Yep.
Okay, good, good. So I've got your answer to Lynxmotion. We'll save that for the end today because I want to go in as much detail as we have time for, and I want to show you where to find all the answers for that kind of
Chris,
stuff.
do you have a purchase manual?
Do I have a purchase manual? As a matter
A
of
new one?
I do. That would be 16, 17.
And if you haven't had the chance to download the new workbook, if you get on PLTW's website, even if you don't get on their website, if you just go to Google and you type in purchase manual project lead the way, it'll take you right to the download for what you want here. And there's at summer training we kind of teach them how to use this. So this is one of the things I guess we kind of skipped a little bit in the beginning, so we were waiting on the newest, greatest, neatest purchase manual. Especially schools that are in like New York, they have to have a whole bid process. So Project Lead the Way decided to get the heck out of New York, so they didn't have to do that anymore. But they still do at least give you multiple vendors for some stuff. Some stuff, unfortunately, like the bench mill and the Vex, it pretty much comes from them. You will find if you did not want to buy the Vex POE kit, you probably have some local people that can get you parts cheaper than buying the whole kit again, even if you probably bought the whole thing outright. If you go through, you'll see there in the yellow, that'll be one of your prices, and then over in the next column there's another vendor, and the next column there's some of them that even have 3 vendors for things that you can buy stuff from. If it only has 1 vendor, then pretty much that's the place they've decided to try to get it from. Unfortunately, like number 9, the extension cables, they're just PWM cables. They really could come from anywhere. They only have Robot Shop on there. That was a good price that we found, but really those cables could come from anywhere. There's nothing special about them.
Yeah, and if this is like when you teach this the first time, you go through the purchase manual and say, you know what, okay, I'm going to make this easy. And the prices are very good, and they're very competitive. But everybody has their own pet suppliers. I would say go through, make sure you know what they are, and then you can get what you need from other places. Like Jim said, you can buy these. I can buy these on Amazon for under $1 a piece if I buy, and I can buy them by the 100. So it's saving me 50%. But I would go through and click on them, check them out, go to get this part number, see what it is first.
Well, it's just like that cable right there. That's a 12-inch for $1.95.
Right.
If you truly get on Robot's website, Robot Shop's website, the 24-inch is the same darn price. The 6-inch is the same price. So you could go big or you could go home. But some of that stuff you can get other things. Project Lead the Way has just said the 12-inch was a decent size, so that's what we're going to put on the purchase manual. That there's nothing ever saying you can always go better than stuff that's on the purchase manual. It's just supposed to be in your school's agreement that you will maintain equipment and supplies that are at least as good as what Project Lead the Way is recommending.
And yeah, I just want to check on this. And you'll see too that there's a lot of stuff. Let me just see. This is oh no, this is the right one. It's the link is correct. But
are they out of stock?
This description is not. Is it out of stock? Nope, it seems to be. Notify me when this product, yes, it is out of stock because I have one on order. So forget it, Jim. Mine's in the queue before yours. You're out of luck. Sorry, buddy.
Well, I'll just give Mario a call.
Well, you go ahead. You call Mario. But take a look at some of the stuff on here, too. You've got, like, wrench sets, hex key sets, pliers, slip joint pliers, benchtop table. Some of the stuff you might have in another room that you don't need all the time, that you just might have. So, your price could go down, and you might not want to buy it from Home Depot. You might have a local place. You might want to get it at some of these little things. You can get it at discount stores.
Talk about Harbor Freight.
Yeah, Harbor Freight's a great place to get some of the stuff that you use once or twice a year that you don't need to be top-notch on. And here are the end mill. That would be these devices and the engravers. The suppliers are MSC, and these are the MSC part numbers right here. And, you know, Jim, you said you get a pretty good hefty discount from your MSC person, don't you?
Yeah, so when you contact MSC, you need to figure out who your educational person is. And even that person, it depends on who you talk to, can get you better prices. So if you get the regional person, they can give you better prices a lot of times than your local can. So they can really look at their profit margins, and some of them can really, really help you out, and some of them will say they're helping you out. For the most part, I get a 33% discount off of anything that's their stock prices.
Because I don't get that kind of discount here at my MSC.
MSC, and I get free shipping and handling as long as I go over $100.
Nice. Oh, that's great. Other stuff, don't forget to go down far enough to get once we start doing Lynxmotion stuff in a couple weeks, don't forget you're going to need these optical isolators. You might want to grab those now. PDP, resistors, syringes for the hydraulics. Do either of you have the Vex pneumatics by any chance? I would use those instead of the syringes for the hydraulics and such, but they're on there too. So just don't forget that stuff is on there also. 9-volt batteries are gone. You don't need any 9-volt batteries.
It also amazes me, they've asked us every once in a while for input on this whole purchase manual thing, but if you go down just a little bit, Chris. If you look, oh no, 24.
We just changed this too, Jim, so I don't know what happened.
So number 25 is the 1/8" end mill. Says that belongs in 1, 3, and 4.
That belongs what?
It says it right there in the column O. It says that it belongs in unit 1, 3, and 4. It doesn't belong in 1, and it doesn't belong in 4.
No kidding. Look at that. That's interesting. What would you do?
And the female crimp terminals, I'll buy that they belong in 3 and 4.
Yeah.
The edge finder somehow belongs in 2.
Interesting.
4. That's weird.
That is weird. I got to be honest with you, I've never really thought much about that column. I've never really looked at that column in depth. Huh.
Because 2 is the only thing, unless they're trying to say, oh, it does not belong in 1, 3, and 4.
I don't know.
Unless that's what they were trying to say there. But nobody's perfect.
All right. So, yeah, and like Jim said, you can do a search of this purchase manual, Project of the Way purchase manual, and you'll get the link to the Project of the Way site. And you get the latest, greatest 16, 17 purchase manual. It's up for download now. You can download this. When you come to training, you'll go over this, and you'll see how we use each of them in projects that we do in the classroom. So you'll have an idea of how it works. Just so that I think that takes care of the question about how do you get your end mills, etc. They're here. Your supplier is here. Sometimes I get them from Enco. They send me a sale flyer. I just make sure that I get the extra long tools because I like to make deeper, bigger containers and deeper projects. So I make sure that I have at least 1 to 2 inches of cutting flute length. But that's personal preference. I would just go get 2 of each of these to start my year and see what you use and see what you don't and go from that.
Same thing with line item number 32. 32 seems really, really expensive. That's the material that you're going to make your containers out of. So you're looking at, what, $137 there for 1 sheet. It's a prototyping material. It's designed to make your machines last longer. It's designed to make your tooling last longer. You can ramp up your speed. You can ramp up your depths of cut and those kinds of things. It's designed for prototyping. It's kind of strange that they write the word particle board there because that's not what it is. But anyway, so it's just partial board.
That's a partial board. Half a board.
So the big thing that Chris and I are going to do this year is they sell other properties of their material. The 450 all has to do with the density of the material, the kind of edge that it will keep, all of those types of things. You can go with the 440. The big deal is you cannot buy the 440 in a partial sheet. The 450 is the only one they sell in a small sheet. So you can get the price cheaper if you're actually willing to buy more of it up front. So if you're willing to buy a full sheet, you could actually get a full sheet cheaper than the 440, 41304. If you bought one full sheet of like the 440, and I don't know that you're really going to lose that much. That's really what we want to kind of do some testing over. I know it changes colors a little bit. It's not quite as brown. It's got a little bit more of a pinky color to it, but
yep, it's a little pinker. But I used it this year, Jim, on our projects that we did, and we just stained it with dark walnut. It looks just like wood, and for everything we're ever going to make out of it, property is just fine. And it cost me about $100. This price was not the price that we got. It was like $480 for a full sheet, and I paid $320 for a full sheet of the 440. So I saved over $100, and it works just perfectly. And that's with a 440.
So that may be.
Good afternoon, guys.
Hey, who's that?
This is Steve Szymanski.
How are you, Steve?
Good, doing well.
Excellent.
My second meeting with you guys.
Excellent.
Hey, this is Nick Carson. I've got a question about that board.
Sure.
The guy I replaced, I just got to this school February 1st. My first job out of college, I'm green. And he left me a whole bunch of 4x4-inch, 3/4-inch pine boards.
Okay.
Use for practice runs on the mill. What do you think? Good, bad?
You can use those. I would use those for the engraving stuff. I'd be really careful though. Just make sure. What kind of mill do you have?
I got a ProLite.
Good, excellent. So you've got a really good mill. Just make sure that you clean up very, very well. Don't leave any of the dust. Make sure you clean up after each period, because what happens, we used to cut wood all the time too, and my older machine has a little rust on the table, because if you leave it, the wood will soak up the oil right out. It sucks the oil right out of the metal, and moisture gets into it really quickly. Just make sure you clean it really well. And I used to, every day when we got done and we vacuumed it, I would give it a shot of WD-40, the table.
Okay, we've been vacuuming it, but I'll give it the WD-40 too. I really appreciate it.
Yep, give it a shot.
There's also, from like MSC, I buy a can, it's DEP, and it has Teflon in it.
Yeah.
So as I wipe down the machines with it, it actually leaves a pretty heavy Teflon residue on it that keeps me from rusting. The only other thing I'll warn you is Intelitech does not like wood onto their machines.
Right.
If things go wrong with your machines, they'll tell you that the reason is because you're using wood and it gets into the bearings and it gets into the motor, because it's not a sealed motor. It'll just kind of suck that in there, and they'll claim that it was things that you were using. The other bad part is if you really look at like a CNC router, things that are designed to be working with wood, you're pushing spindle speeds of 5,000, 10,000 RPMs, and your machine is going to max out at like 2,000 RPMs. Right. So it's very, very easy to burn the wood and to dull up your tools really quick, because you're not truly spinning at wood speeds.
And the one thing I found, if that's what you're going to do too, I found that we used to make larger stuff. We used to glue up wood stock, and we would cut out the wood stock. But the best investment we ever made was going to solid carbide tooling. Yeah, some of the tools were $43 to $83 a piece for the bigger tools, but it never burned. It never wore out when we were cutting wood. It was one of the best investments we made when we were cutting wood. And also, just so you know too, when you call Intelitech, because the spindle burns out, they'll ask you what your materials you're using, and you can tell them you're cutting marshmallow with it, and they'll say, well, yeah, that's why. It's always going to be the fault of the material. It's never their machine, just so you know.
Is there any way to, I noticed that bearing up top isn't a steel bearing. Is there any particular lubricant you recommend to place around that seam to wick in there? Or do you take yours apart and grease the bearings? What do I do there?
There's a really awesome video on how to maintain your milling machine, and they had an actor come in and They paid him pretty well, I understand, and it was kind of like a top delic. And he did this great video in how to maintain your milling machine. Basically, if you look in the manual, they say that those bearings are sealed, meaning that they don't require any lubrication. It comes with a manual. Check the new manual. The old Pro Light, not the Super Pro Light, but the old Pro Light said that the bearings are sealed and you don't need to lubricate them. I would look, if you have the Pro Light 1000, the Super Pro Light, or anything, the bench mill, I would look at your manual. There's a whole section on maintenance. And I would look in
I read that. I followed all those steps.
Okay, so then you should be fine. You should be. And we always, if you're cutting wood, I would have a device that's vacuuming while it's cutting, whether it's a device or a kid holding the wand from the shop vac next to the tool. That works also.
Okay.
That way it's sucking up the dust as it's coming off your part. It's not going into the bearings. And last summer and the summer before, all of the CTIs, all of their Super Pro Lights, the spindle bearings started going. It happened to us at Kentucky. It happened to Jim at Cal Poly. And all of a sudden, we're calling and we're like, what's going on here? And they blamed the fact that it was wren shape. But what we told them you don't understand is these machines work for 3 days a year. And they're like, oh, that's because you have to do the warm-up sequence and the blah, blah. And it's always something else. But those bearings are susceptible to wear. So, I know people who try to hog out half-inch cuts, at 20 inches per minute. Take it easy on it. You've got 20 parts to make for 20 kids, but that machine costs $15,000, and you want it to last. So a kid does not mind standing there watching it. They really don't. They're okay with it. So I would take the time on that, and I would just make sure that you're vacuuming all the time. And
the other I have found, because even on my Haas, if you don't run it for a certain amount of time, it absolutely won't even let me do anything until I run a spindle warm-up on it.
Right.
So I've created a simple file that it just ramps through your spindle. So you run the file, and all it does is not doing any cutting. You don't have to have any tool or anything in it. You just run it, and it runs 300 RPMs for 2 minutes, and then it ramps up to 350 for 2 minutes, and then it ramps to 400 until it gets all the way up to full speed. And any time that your mill sits for any length of time, you want to do that. You want to get everything warm back in there. You want to get all the oil and everything redistributed in there. Otherwise, they'll seize up.
And
okay,
I do that manually. I'll just turn it on. Before we start it up, I'll turn it on and leave it on some low spindle speed, the manual spindle speed low for a couple minutes. And I'll spend about 7 to 10 minutes and just while I'm doing nothing. And then every couple minutes walk over and turn it up a little bit until it's running full speed for 2 minutes. And I seem to have much better luck. My old Pro Light, the one I've had since 1999, knock on wood, is sitting on my back table. I've never done anything to it. It just runs. My Super Pro Light, I've changed the spindle bearings twice. And ever since, I'm a stickler about the warming up and the vacuuming. And as long as you keep the warming up and the vacuuming, and I think the bench mill has a dust collection port.
No more. No more. No more.
No, the bench mill does not have a dust collecting. The thing the bench mill has, the other ones don't have, is it has a one-shot oiling system.
Really? Okay.
Yeah, it's got whey oil that's in the back, so you just pump it one time and it pumps the wheys.
Oh, good.
Most of the rest of them, the Super Pro Light, the Pro Light, all of those, they've got little joints next to each one of the whey parts, and it comes with this little canister. Mine came with whey oil in it.
Yep.
You just plug it in there and you squeeze it until it comes out, and you oil up all your wheys and everything that are underneath those rubber covers. But no, they don't have any kind of dust collection system to them.
I thought the enclosed ones have the one we used at Duke. It wasn't the bench mill, but they had a humongous one. No, that one too, but they had a humongous one. It had a dust port on the back that you could stick a shop vac into and turn it on and leave it on. I'll look up which one you had, but that wouldn't be a bad idea either. Just to have the vacuum sucking on it all the time to keep the dust down. And I will post a, one of my guys in my department just found a vacuum cleaner that has half the decibel level of a normal vacuum cleaner for under $100 at Home Depot. And it's a really good one, and it's under $100 at Home Depot, and it's half the noise. So if noise really bothers you, this one is really spectacular. He's had one in his shop for a long time. He just bought one to replace it. It lasted about 7 years in his wood shop. So that's kind of cool. I'll find out what that was and I'll let you know. All right.
I'd like to know that for sure. Since we're talking about it, you talked about lubing up I've got the expert mill, and you talked about, I'm not sure which machine, but hitting it with WD-40, especially if you're with wood. What do we need to be rubbing down with that? I guess because I haven't done anything like that, so I guess
I just spray the metal table
anything steel
in the vise. The metal table in the vise. Something my old one has. My new one has aluminum tool holder, so I don't have to worry about that. The old one has the steel tool holders, and I'll spray the tool holders down too.
Okay.
Otherwise, you're sitting there with some triple grit steel wool trying to get the rust back off of them.
Right.
Otherwise, the tool holders, the tools will get jammed up in there, and
And then there's joints. There's like places to squeeze to pump in some other kind of oil around the machine.
I've not worked on an expert in a long time. I know my Pro Light. There's one underneath the bed that's actually kind of hard to see on both sides. There's one along the sides. It's just a little silver round port that's got a ball bearing in it, and you just take the can. It's got a special tip on it, and you just shove it in that ball bearing, and then you squeeze the gun or squeeze the little can, and it puts the whey oil into it.
Yep.
If I'm right, I don't remember. I haven't worked on an expert mill since the last time I taught at Kentucky, so I don't remember if they have those points or not.
I'm pretty sure they.
Okay.
I'm pretty sure they do.
I don't think they changed it until they went with the bench mill, and then the bench mill and the pro mill both have the one-shot systems.
Nice.
Or like a Bridgeport.
Nice. That's a step up.
Would you recommend buying the end mills that have two heads on them, so when they get worn out, you can reverse them?
Nope. I buy the.
Nope.
I'd like the
Too long.
You make them long, and I used to find that when I had the double-sided one, if a kid broke one, they'd look around real quick and they'd try to just reverse it, and just not home the tool, not do anything, and then wreck the other side too. So there really is no advantage, and I like them with longer cuts so that I can cut deeper and make bigger boxes, containers. And when you get them longer like that, they generally don't come double-ended.
No, well, that and most of the newer mills, the tool holders that they have are not a deep tool holder. So you'll bottom out before you can actually put the tool in there. The only ones that are all the way through tool holders are the ones for the original Pro Lights and the Super Pro Lights.
Right. Oh, that's right.
Expert and up, the tool holder is very shallow.
I've got the Pro Light. I accidentally ordered the double-ended ones, but I might go back and see if I can revise my budget.
Well, if they fit and you got them, use them. It won't hurt. You know, just make sure you don't cut
You have a Pro Light?
in the size of the teeth, and you'll be fine.
So you have a Pro Light?
Yeah, if they haven't ordered them yet, I might just switch to the deeper ones. I didn't even think of how deep
The big thing about the Pro Light tool holders, the original ones, they were a C.R. Clark tool holder, which is kind of a pain in the butt to find extra ones, but they've got a set screw in the side of them, and you're supposed to put that set screw. Each one of your end mills will come with a kind of a flat spot on it that you'll run that little set into, and I have some double ends, and they work just fine. It just comes completely out the other end because your tool holders are completely empty. You trying to look up their tool holder?
Yeah, no, not the tool holder. I wanted to just, I was just curious, and while you guys were chatting, I was going to look up one of these tools because I'm wondering if these are the yes, they are. Oh, wow. Okay, so they've got the tools in the manual, purchase manual, are the ones that have 1.5-inch flute length. So
all of them are all of the ones that are there in the purchase manual are the ones that are designed for the containers.
Yes.
So they're designed for extra depth so you can get inside the pocket. The only bad part about them is they have kind of especially the ones with a smaller diameter, they have a kind of a high-pitched whine to them. So they squeal a little bit just because of how much they vibrate.
Yeah.
And the longer any tool is, the more it will hum or squeal.
Alrighty. Any other questions about the programming inventory workbook, commonly called the purchase manual? Beautiful. So you want to head right into Robocell?
Sure.
All right, let's do it. So I think if I remember, last time we met, we worked in cell setup, and Jim did, help me remember here, he did teach and record points, right? So do we know the difference between teaching and recording points?
I do.
Yeah. All right, so let's do this. I'm going to give a short little mini lesson on what teaching and recording points are and what the difference is. So I'm going to open up a different project because we really don't need a milling machine to do a pick and place. So we're just going to go up here to a pick and place and open that one that I've already done. It's already set. And let's take a look at this one. So here's a pick and place. If I open my gripper and I drive my robot to the position and I hit this button right here, the record position button, that would be this button right here. If I hit that button, I'm recording it. And what that does is that moves and that records the position of all of the joints. And so if I were to say view positions, and I look at all my positions that I've saved so far, I can look and see that, all right, here's the X, Y, Z coordinates of all these points. But you see the joints, these numbers, these random numbers? Those random numbers are the encoder counts of each of these axes. So basically, recording, all it does is record where the robot is. So then I move it to a point above, like Jim showed you last week, and I hit record, and it remembers where all these joints are by numbers. It's simply by numbers. So that's the easiest way to do it in terms of you don't have to do any math, you don't have to do any thinking, you just have to drive the robot around. Now when you get in front of the robot, you lose these icons. These icons don't exist in real life. These are in simulation only, where you can click on an object and it magically goes to it. It doesn't work like that in real life. So in real life, what you have to do is you have to know the Cartesian coordinates. And then what you're doing then, so recording is wherever the robot is, you click record. Let's say, for instance, I wanted to be more exact. I wanted that to be 17.5 units off of the table so that it grabs it in the same spot every time. All I have to do is go to expand, and now I get my teach positions. And those
As long as you're on Pro.
Right. For those of you that are playing along at home and you have yours open and you're looking and you're like, I don't have my teach positions. That's because you're in loser level 1 or loser level 2, as my kids call it. So you want to make sure you're in the professional version. You want to click on Pro, and you'll be able to get that window. If you're in loser level 1, you can't click on that expand. You lose a lot of functionality. So make sure you're in Pro mode, and you'll be able to click on expand. And when I put position number 1 in there, I can say get position, and it will tell me what each of those positions are. And now I can go in here and say, no, I don't want Z to be 10. I want Z to be 17.5. I can type 17.5, and what your kids are going to do the first time is they're going to come over here and they're going to click record. And you know what it's doing? It's recording where your robot is every time. You have to click on the teach button. If you're typing stuff...
Just have the kids go get the undo button.
Oh, yeah, go. Oh, there isn't one. Oh, bummer. Do it again. So you have to make sure you hit teach. The other thing that I want you to see about this, I'm going to place this back to here. After you teach all your positions, you're good to go. This pitch of -90, kids forget this, and they'll put 0 in here. If you take a look closely at your the head of your robot, it's got this big honking motor on the end of it. And -90 for pitch is this straight up and down perpendicular to the table. If that's not -90 and you accidentally type 0 in there and you try to go to that position, it will not go. the position is in, because 0 means this thing's trying to go to a position back here that it can't get to. So 0, and kids will, it's not, I know it's not, in everything. So when a kid from the back of the room says, it's not in the workspace, tell them, pitch is not 0, it's -90, and they'll think you're magical because you'll know from the front of the room. That happens all the time. That needs to be -90. If you want it perpendicular, you can make it something else, but just stay within the realm of what actually works. And by playing with it, you'll figure out what actually works. So teach, you never have to drive the robot. You can open up a set of coordinates, look at the coordinates, and just type them in. And then the robot will go to all those sets of coordinates. Just understand that the coordinate system, X, is this way, straight out. So if I were to, I'm just going to reset my work cell here for a second, and I'm going to move around a little bit. I'm going to go to my movement box, put it in XYZ mode. So X-axis, the X-axis is straight in and out, and you would think that that's the Y, or that's the Y-axis. In the Cartesian workspace, that's the Y, but now in robots, that's X, and in Y is back and forth, left and right, and Z is always Z. Z is always up and down, and you can move it straight in all of those different axes. So you type in your X, Y coordinates. I can say show object, because kids will do this all the time. Here's an error. Oh, but Mr. Hurt, I didn't put it at exactly 400, 0. Do I need to? Well, if you want it to work, and you're teaching it positions, you need to teach it the right positions. Yeah, you need it to be 400, 0. And if it's not, you can very easily go into File, Edit 3D Model, and it'll load cell setup, and you can go in there and double click on that block and make it whatever position you want it to be, and make it so that it's correct, and it'll come in and load back in here. So that's teach and that's record. The program's exactly the same. It does exactly the same thing. It's just that one records it and one teaches it. Recording as you drive it, teaching as you enter points. All right, any questions on that? For teach and record? No? Oh, good, because we're going to do the hard stuff now. So what I want to do is I want to spend about 15 minutes and do roll angle and stacking. And, oh, I lost all my windows. If I go to window, say simulation and teach, it'll put everything down. But I want to do the roll angles activity, and I just so happen to, whoops, not there. It just so happens that I happen to have my Robocell activities right here on my desktop. I make a folder of them, and I have them in the LMS. They can go in here and they can get their activities, and the activity that we're going to do now is called stack and roll. They can open this right up. I just happen to have the Word documents on my desktop, so I'm going to use them there, but you can get them right from the LMS. It's activity 3.1.2C. C is stacking objects and using roll angles. So what we're going to do now, according to this activity, is have some fun. We're going to stack some blocks. And we're going to start with 3 cubes. We're going to put them at these positions. And again, if you put them at these positions, you can teach them, and it's very easy to do. It takes a lot less time, especially since the activity gives you all the positions except for this roll angle. And note that position number 2, position number 12, the roll angles are yellow, and 3, 13, and 33, and 23 are all blue. We'll figure out why in a minute. So the kids look at this and they say, what? I have to calculate roll angle. And first they tweak when you tell them you have to calculate something. And then they say, oh, crap, I have to do it 2, 4, 5, I have to do it 6 times. This is crap. This is like math class. So then we go down, you take a look at the activity, and really what you're doing, you've got those 3 blocks on the table, and you're going to pick up block 1, go to point 11, bring it over here, and set it right there. Setting's the key. I tell them they're stacking crates of eggs. So you have to set it down. And if you use the numbers here, plus 40, plus 40, plus 60, it'll set them perfectly. So you bring it over to here, set it down, then you come over to 2, pick it up, and set it down. Sounds pretty easy. That would be awesome. It'd be very easy if these things were oil drums, wouldn't it? If these were oil drums, we wouldn't have to worry about the fact that when I pick up this block and I drag it across here, my gripper doesn't change angles. So when it stacks that block on top there, it's crooked. The corners don't line up. Whereas if they were barrels and round, it would stack easily, really nicely. And then the kids get mad because they just want to stack barrels all day long and they don't have to calculate roll angle. And so then we talk about calculating the roll angle, and we figure out that there actually is a reason in life why you would use tangent or the inverse tangent function. They ask their math teacher, when do we need to use this? And the math teacher says, right now, because you're getting 50 problems for homework. And I tell them, well, here's where you need inverse tangent, and here's why. So to calculate the roll angle, you have to look at this as the base of the robot, looking straight down bird's eye view. Here's your 3 blocks. Now, how many of you remember your geometry? You can just shake your head yes and pretend that we do, because I didn't remember this until, oh yeah. If I draw a line straight through my base, and I have a line straight through these, it's 2 parallel lines. They're 2 lines that are parallel. What's that crap from geometry class that says if you bisect a line, 2 parallel lines, opposite interior angles are equal, aren't they? And the kids are like, yeah, because they just did this in geometry class, so they know this. So the angle at which I turn my robot is equal to the angle at which I have to twist my wrist to make it compensate for that angle. And now the kids are like, wow, okay, I get it. So how do I calculate that angle theta? And I say, well, take a look. It's a triangle. And this triangle, isn't this the hypotenuse? This is the opposite, and this is the adjacent. So I just come over here, and I do this, and they punch that into their calculator, and they get the wrong answer every time because they forget about order of operations. So you have to take the negative 100, divide it by 300, and hit the equal sign. And then they take that and find the inverse tangent of that, and they will get 18.35, which is the correct answer. And then they can go back to this table, and they can pump in 18.35 for number 2. And then they're like, okay, crap, I got to go do number 12. And then they come down, and then we say, well, wait a minute, isn't 2 and 12, isn't this the position 2 and position 12? Aren't the x and y values, aren't these x and y values the same? 2 and 12? Yeah, they're the same. Oh, the only thing different is the z value. And z is not in this equation, therefore it's the same roll angle. You might get a kid really quickly that figures out, well, if this angle is 18, then this one must be double, because they look at it, and they are right. They happen to be right. It is double. So if they just double it rather than calculate it. You type in those numbers here, you teach these positions, you calculate those roll angles, and then when you actually run this program, well, let's try it. Say File. Let's go open up the stack and roll, and we run this one single cycle. We'll go to the top. We'll say go single cycle. I'll turn on my, and we'll see what happens. It picks it up, and if you watch carefully, see how the gripper stays straight now? Whereas it would not stay straight if you didn't change the roll angle. So there's that one. It comes back down. It'll pick that one up, and it'll change the roll angle to half of what it was from when it was over here. And then boom. And what I do is when I check these out on the kid with the kids, I check and make sure that this line, and this line are all straight. They're perfectly straight, so that I know they used go linear in the program over here. Sometimes the kids use go linear for everything, and that's just fine. That's okay. But you can also go to View and say Show Positions. And again, you should be able to go here, and you should be able to see that, all right, here's my roll angle. Okay, negative 18.4, negative 18.4, and the rest are 33.69 negative. And that's how I know they've done it right. They hand in a couple screen captures of this, and this. They screen capture that, and they hand that all in, and poof, I've got proof that they've calculated the roll angle or stole it from the kid next door. If they guess, you can make it look good by guessing, but it won't come out accurate to the nearest hundredth of a millimeter. So that's how you can check and see if they actually calculated the roll angle. But so that's how you do a roll angle. This is the whole activity. And what I started doing last night was and these will be available shortly. I just put them up on our YouTube channel. So I did activity A, pick and place, record. Activity A, pick and place cell setup, and activity B, and I have the audio and I did the video. So this is a 6-minute video. This is an 8-minute video. This is a 16-minute video. And I've got some of the other ones, and Jim's going to do some too. And eventually you're going to be able to go check these out and go through them step by step, because I didn't go show you building the cell for this. If you can build the cell for A, you can build the cell for B and C and D and E. It's really pretty easy. It gets pretty easy as you go along, and kids get pretty good at it. If you ever need a refresher, we'll have all of those on our website that you can go check out and watch the videos and see some of the intricacies and some of the things that the kids get hung up on. The negative 90, putting negative 90 when you're teaching positions in pitch all the time is really, really hard. Kids forget about doing that, and when they forget about doing that, it hits itself all the time, and it just doesn't work. So little things that you'll find out as you go, that the same thing happens over and over. That's one of them. Anybody get into this in the classroom yet? You really get into this yet with the kids? Jim, you probably don't do this in your class, do you?
Do which one?
Any of these? You probably. I was just checking to see if anybody was still with me.
I do them all. The only one that I do differently is, and like I showed you last time, I do the record, just everybody together, and they do lots of positions. And then the teach I do just like it is, but they do it with me. We don't open up the activity. Roll angles, they do identically from it. Go circular, I make them put something on the table, and they have to go through it the first time before they do their initials.
Oh, nice. That's a great idea.
They got to go like they were trying to, I don't know, weld around something, so they're going to kind of point the gripper at a cylinder that they put on the table,
right,
and they just kind of make it go around it.
Oh, good. Would you, when we do the videos, would you do the, I like the way you do the relative, and you only do 1 or 2 of the relative moves rather than all of them. And maybe I could talk you into doing that video.
Sure.
I'll buy you a root beer at the summit next week. How's that?
As long as it's got fire in it.
Okay. Hey, is anybody going to the summit next week?
No, my district won't let me.
No.
I just texted the guy that I was replacing, and he said he already covered this with him. Is it all right if I just take notes on this for next year then?
Yeah.
Okay, I appreciate it.
Mm-hmm. Sure, anytime. So we only have about 15 minutes left, so we're going to stop there with Robocell for this week. We'll pick up with the other activities. We'll do relative positions, go circular, and variable, at least those 3 next week, and questions. So if you go through these and you have questions, you know, I'll have the videos for relative and go circular shortly, and I'll send you links to them all. But we're going to talk about variables also. We might get into palletizing and storage and handshaking. Those get a little tougher, but we'll save those for next week, because there were some questions about Lynx. There's a couple people who are into the Lynx had that we wanted to answer for you. So if you want to take off, feel free. Otherwise, what we're going to do is talk a little bit about the Lynxmotion stuff. So the question was
Handshaking.
Handshaking. How do we do handshaking? Well, that's a great question. So what I did was I went to go
to that awesome website.
Yeah, well, we've got the awesome website too. We've got a whole bunch of different resources. If you go to the LMS, now this is the real one. This is the one that you have. In the one that you have, if you want to be able to do handshaking, then the activities that you want are in lesson 3.3 robotic programming and usage, which is the Lynx lesson, and they live right here. So you've got Lynx input, recording a sequence, Lynx handshaking with VEX, control system handshaking. What this means is robot to robot. Control system handshaking is VEX to VEX, and Lynxmotion to control system handshaking is a robotic arm to a VEX component. So I can make VEX talk to Lynx and Lynx talk to VEX and back and forth.
And I know we had somebody say last week that they had Fisher Technics, and if you go back out to that main page, you can see that you have control systems as control systems, but you have an FT next to them.
Right.
Oh, you're in the VEX one.
Yep.
So if you go back out one.
Yep, you go back one and get your files.
You can get the FT and you can do the same thing. The biggest difference is with the Fisher Technics, you don't use the optical isolator, you'll use a relay.
And that would be right here. They said, too, that this was going away this year. So I think if you're using Fisher Tech, I think this is like bonus time. So I would make sure that I have copies of all of those just in case it goes away. You don't want to be stuck without it. Those are not being updated anymore. The VEX stuff is still being updated. So inside this activity, the one that you're looking for, if you want to talk a robot to a VEX, that's letter C, activity 334C. This is the activity, basically. You can go into the resources. There's a PowerPoint. There's a VEX document. The PowerPoint will show you the wiring, how to wire it explicitly, step by step. There are documents, Word documents. You can find them also in the files. I clicked on files and I just started digging around in the files, and I can go to the files and I can find all these different files on Handshake, Lynx to Lynx, wiring, Fisher Tech to Fisher Tech, Fisher Tech to Lynx wiring diagram. So here's a Word document. Uh-oh. We got the unicycle panda. We're in trouble. At least he didn't fall over this time. This morning when I opened this up, he crashed. And here's a wiring diagram of how to do it. But notice I opened up the Fisher Tech one. So this isn't the optical isolator, and this is the VEX. Why don't I kind of pick the right one? Yeah, good luck. So those happen to be all the Fisher Tech ones that I searched. I'll show you the other one in just a second. But there's also this really cool website, ChrisandJimCIM.com. If you go to Solutions, you go to Flow Arm Solutions. Is it Flow Arm Solutions? I want Lynxmotion Solutions would probably be the best way to get that, because how do I handshake a Lynxmotion AL5D arm with a VEX Cortex? And if you type in Handshake up here, you'll get this page. So here's the solution, and it gives you how do I go from a Cortex to the SSC32, and it gives you, because that's what everybody yells at us for. They yell at us, well, you didn't give us a program. Well, it's in the PowerPoint. It's all in the PowerPoint. But if you want a whole program, here's a picture of it right here, step by step, with remarks. How do you send a signal from the Cortex to the SSC32? One of the big things you want to look at is, as you do this, you make sure that you're using a digital output. All right. If you use a digital output and you say sensor value signal equals this, sensor value signal equals this, by configuring that as a digital output, on is on and off is off. 1 means on and 0 means off. If you use an LED, it's backwards. And when it's off, it's on. It's the way that the VEX Cortex is wired with pull-up resistors. If you want it to work right, you have to use a digital output. And people call us all the time and email us all the time. Why doesn't this work? Why doesn't this work? It's because they didn't read the directions in the PowerPoint. How do I make the two talk back and forth? Here's a program where you wait 2 2 seconds, and then forever while the sensor value for the robot input is 1. And at this point, what you do is it's waiting for the robot to send you a signal. And then in your flow arm, Robotic Studio, flow arm project, lead the way software, all you have to do, come on, you can do it, there we go. All you have to do is say, like at this point, if I want to turn on output number 8 with this position, I click on that position, I turn on output 8, and I say record. Now, whenever I get to that position, output 8 is going to turn on, and if it's wired correctly, this will see output 8 is on. It will do exactly what you want it to until it's not on anymore. And then once it does its thing, you send a signal back saying off, and then the robot sees that it's off, and it can come get it and pick it up and do its go pick it up routine. So it's really pretty simple. Just make sure you use digital outs and make them, then 1 is on and 0 is off, and it'll work just fine for you. And when you, let's say for instance, let's add another one, add another one, add another one, add another one. Okay, so let's say right here I want it to send a signal. I click on that box, I turn the signal on, and I say record. But what you have to remember to do is you have to remember on the next box, though, to turn it off so that it's not always on. And you see how I forgot and I left them on? Record it with it off. Record it with it off. Record it with it off. And now you see that little light. If I start over here and I say, please play my, now I notice I didn't make it do anything, but you see as it comes through, I'm waiting, I'm waiting, I'm waiting, and I go up and over, I set it down, and then when I get to this point right here, bang, I tell the robot I'm done, go get it, and then I sit there and I toggle a pause right after this point so I can add another point. I toggle a pause right there and toggle a pause before the frame. And so then what it does is it sits right here waiting, 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 waiting until the robot, you use robot C to send a signal back on one of these inputs, A, B, C, or D. Actually on B or C, or C or D, B or C. All right, makes sense? Awesome. And I download, there's a, you can take the, if you go to that cool website here, there's a download button. If you can download that as a PDF file, you can use that in your classroom too. It tells you why it works, what it works, and shows you all the remarks too. So that's there if you want it. So Nick and Tom, you guys have any other questions?
Well, the one other question my kids were having as we were going through, after we spent all the time in Robocell, they got so used to the idea of their relative points and recording those,
Yep.
and having numbers for them. There's no ability to do anything relative in FlowArm, is there?
No, not in FlowArm. FlowArm is basically record. So you,
Servo control.
yeah, it's servo control. You're sending it here. It's recording the positions of all these servos, and that's it. That's all it's doing. It's pretty basic, and we're trying to talk them into allowing, multiple lines and ifs and ors and stuff like that. So if you can do this, and then you can get pretty complicated by changing, adding more series of steps to this. I found it really confusing. The kids found it really confusing too, but they're really pumped that if you can do a pick and place with this, and the handshaking is easy. So you pick it up, you place it, and you wait until it's done with something with inputs and outputs, and then you go pick it up and send it on to the next machine. That's pretty easy to do. And kids get all pumped up when they successfully wire it in, because the wiring takes a little bit too. So if you follow, are you using the the optical isolators?
I've got to try and track them down at this point.
Okay.
I didn't realize that we were missing them until I went to go start looking into the handshaking and went,
Gotcha.
something's missing here.
Gotcha. Yeah, and you really need those, or this doesn't work. It will not work with the Fisher Tech things, with the solenoids. It does not work with those. There's not enough current to drive those.
Okay.
So that definitely won't work. You can order them pretty, and they get here pretty quickly. Use from the purchase manual. Use the
Those ones from MSC?
Yeah. You know what though? Hold on a second, because I want to see where the purchase manual. The optical isolator is right there. DigiKey. DigiKey is fast. You'll get it pretty quickly. Electronics Express, they won't even acknowledge that they don't have them in stock, and you won't see them until the second Tuesday of next month.
Got it.
So I would.
And does DigiKey have a minimum purchase order volume?
Nope. And last I remember, they were pretty cheap if you bought them in quantity. I don't think.
Yeah.
I don't think there's a minimum. So
Okay.
I would check DigiKey first, and I think I received something that said that it was one of the devices that I order regularly is going to be obsoleted pretty soon, but it was not this part. So you can find other ones that will do the same thing, but I would stick with this one, and it works exactly the same. One of the, let me see if I can find, let's see, what do we got? We got 458. If you got 2 more minutes, let me just show you CIM. We're in lesson 3, robotic programming and usage. The actual PowerPoint is awesome. The handshaking Vex PowerPoint. Some guy I know who has way too much time on his hands makes this crazy stuff in Inventor, like robots, and he can build cortexes and all kinds of crazy stuff, and like resistors. Like this was built in Inventor. Like, so this PowerPoint tells you what all the different components do. And this is a great explanation for kids who haven't had DIG yet. Here's what the optical isolator looks like. It's a little chip. Here's what it looks like on the circuit board. It's really nothing but an infrared LED and an infrared LED sensor. So it's nothing but a light beam. So you turn on this light on these 2 legs, and this switch on this side opens or closes. And the reason you need that is because you could hook up something with, okay, let's not get crazy. I was going to say household current, but you could hook up something that's 24 volts on this side, and you hook that right up to your Lynxmotion robotic arm, and you're going to let the magic smoke out. It's going to be toast. It's not going to ever work again. So if you use this can handle that current, and if you burn something out, you burn out this 72-cent part. And I got to be honest with you, knock on wood, I have never burned out one of these parts. This part has taken a lot from me. I've put in current backwards. Not me. When I say me, I mean the kids. I would never do anything like that.
Of course, of course.
Of course. So it tells you how the relays work. If you're using Fisher Tech, it gives you an example. Breadboards. How do breadboards work? Because you have to make these, you have to put these on a breadboard. So for Lynx to Lynx communication, here's what it looks like. Now, if you just bought your Lynxmotion arms, these boards don't look like this anymore. And you see how they make you take a wire apart and you have to do that to it? They don't do that anymore. So I'm told that when you come to core training, when you walk away with your LMS, it will have the newer version of the wiring diagram so that you'll be able to wire it much easier. You don't have to do that anymore. But there's for those of you who teach DIG, if you like the schematics or your kids like the schematics better, the schematics are there too. So again, it shows you the yellow wire, red wire, black wire using the stuff that you ordered from class. Vex to Vex, the wiring diagram. Lynx to Vex, here's the one that was specifically asked for today. Here's the wiring diagram. You wire this with the resistor. So we've gotten crazy, Jim and I, and we've taken this resistor out and we've put an LED in so that we can literally see when the signal is sent across. So instead of a resistor, we use an LED. Project Lead the Way does not recommend that, because if you're plugging in something more than the voltage from a Lynx arm over here, you could do damage to this. So if you're using Lynx to Vex and Vex to Lynx, putting in an LED, we have found, works just fine if you do it correctly. If not, just stick with a resistor. You'll be fine. And that's pretty much Fisher Technic to Fisher Technic communication. It's all in the PowerPoint still. So, and like I said, if you're using Fisher Tech, grab this stuff down and hold on to it, because I believe that it's going to go away sometime soon. All right? All right. Any questions? Did I answer your question, Nick?
Actually, that was my question.
Oh, sorry, Tom, did I answer your question?
Yeah, I think so. I think going through. I got to go back through that PowerPoint some more.
Okay.
Get a better sense around that place. Nice.
Was there something that the kids didn't get, or is yours wired like this with the inputs with only 2 pins like this?
Yeah, that was when I was looking back through. Okay. That's still what the LMS is telling the kids to do.
Okay.
So I got to double check, because I've got the USB boards, not the RS boards.
That does not work. All you have to do is take this whole, see how there's a black, a red, and yellow wire? There are 3 pins, because one of the things Jim and I said to them, they said, we'd like for this new board to have this, so that you just take this plug, and instead of plugging it over here, you just plug it in for D, C, B, or A. And
okay, so all 3 will go right into their body.
Okay. You just wire it right to it. Just make sure that there's one of these pins says 5V, one of them says plus, and the red wire has to go to plus, the black wire goes to minus, and then yellow goes to whatever the other one is. As long as you put them on in the right order, it works just fine.
Hey, Chris?
Yeah.
I've got to make it to a meeting at 5:15 in the middle school, and it's about a 10-minute drive. Is that all right?
We're done.
I head out?
Take off.
All right.
Take a look at that.
Let me know if you guys
If you have any questions, let us know.
All right. Thanks for all the help you've provided so far. I really appreciate it.
Hey, no problem. No problem. Have a good meeting. I love middle school meetings. Not.
One other question for you guys. Do you have one location over another for the summer CTI training?
Oh, Polly.
Well, I would say go to the one where the cool kids go, and that would be wherever Jim and I are. And we won't.
Well, that's kind of what I was asking by the back door there.
We will know. Apparently, we're supposed to know.
Well, you don't find out till your meeting next week.
In 2 weeks. At the summit, we're supposed to find out where. So by next week, we ought to know where we are. We can let you know where we are. And we don't even know where they are. It's top secret. You know.
Oh, they're listed on PLTW site now.
Right, but that doesn't mean they're all going to run. It depends on how many people registered for all the different sessions. And the numbers you see, like some of them might say that 25 people of 25 have registered. It's all a big farce. It's not be true. The magic numbers come out next week, and we should be able to have an idea of where. I'm telling you what. I mean, if you get the chance to go to Southern California for a CTI, not for nothing, but I'd probably go there, even if it's like Jim and I. You know, I would put up with the 2 of us just to go to Southern California.
Southern California, exactly.
Right, exactly. So I know Southern California and Kentucky have been workhorses over the last couple of years. They've always run at least a half section. We'll find out in a couple of weeks, and we'll let you know at the next. So next week we don't have a meeting. The week after we do. So that week after, we can probably let you know if it's all right. We'll let you know when it is, when and where and what.
That'd be great.
Okay.
Thank you.
Beautiful. Hey, have a great night, gentlemen.
You too. Have a good one.
All right, we'll talk to you later.